14 on that, you're probably cool and ready to go. You can go ahead and start your review right now, but be aware, I'm going to be talking. If you didn't do so hot, you want to watch this. Okay? Your choice. You're big kids. I'll let you make your decision. That review, you can see we are going to mark it in the last block. That last block is all work time. So if not everybody's done the review by the beginning, we'll mark it a little later in the day. Okay? Everybody good? All right. So let's have a look at this. I'm going to go fairly quickly because this is review, right? Those are the same base. So it is 0.3, 0.3 squared. Since there's no letters there, we can evaluate it. It becomes 0.09. If you were to do it with fractions, it would be 9 over 100, which would still be 0.09. Yeah? Kids are often scared about number 2 because it looks very frightening. But what do you notice? They're the same base, aren't they? So all I got to do is my exponent rules. That is -8. That is 6. What's -8 plus 6? -2. So I have -3 over 2 to the -2. What does a negative exponent do to a base? It flips it over. So this becomes -2/3 to the +2. What is -2 squared? 4. 3 squared? 9. Right? It's just the exponent laws. What's weird about 3? Mr. Myers, there's decimals. But where are those decimals? Where are those decimals? In the base. So it doesn't matter, does it? It's going to be 3 plus 4 to the 3 plus 4 over 1.4 to the -2. 1.4 to the 7th over 1.4 to the -2. Is that allowed? With a negative exponent? It's going to go up, isn't it? So I'm going to end up with 1.4 to the 9. Now, I can't do that in my head, neither can you, but there's no letters there, so technically we should evaluate it, right? But that's just using your calculator. I don't really care if you forget how to do that. What's weird here? Fractions. Fractions scare us. But all the bases are the same. So aren't we just following the exponent laws? What should I do down there with 1/3 and 5/3? Add them. Well, what's 1/3 and 5/3? 6/3, which is what? 7 to the 6/3, which is 7 to the 2/3 over 7 squared. What should I do here? They're the same base, aren't they? So what do I do with exponents when I divide? Subtract. So that's going to be 7 to the -4/3, right? Because 2/3 minus 6/3. What does a negative exponent do to the base? Flips it over, so it becomes 1/7 to the 4/3. That's a really hard question. I'm going to stop there for a minute so everybody's cool, because none of those had letters, right? All of those were numbers. If you were going to be in trouble, I would expect 4 would have caused you trouble. But not because you don't know your exponent laws, more because you're scared to add and subtract fractions. Right? Okay. Now we move into letters. X's with X's, Y's with Y's. What do I do with those X's? If those Y's weren't there, what would the answer be? X to the 5th. If those X's weren't there, what would the answer be? Y to the -2. What there isn't allowed? this. So what has to happen to a negative exponent? It's got to move. If it's already in the numerator, it's got to move down. If it's in the denominator, it's got to move up. So that's x to the 5th over y squared. Number 6 is really 3 questions, isn't it? Because it's 10 over 5. It's a to the 5th over a cubed. And it's b to the 3rd over b to the negative 2. What's this part of it? 2. Exactly. What's this part of it? If there's 3 down there and there's 5 up there, how many of these 5s are disappearing? 3 of them. So it's a squared. What should happen to that negative 2? Where should he go? Up and become positive, right? So now I've got b to the 5th. Doesn't matter what it looks like. Everything is just one step. And each of those steps is a step you already know. So there's no reason to be scared by these. There's no reason to take 30 years if you break it into 3 easy steps. If I gave you this as A, question A, this is question B, and this is question C, it would have taken you 5 seconds to do that, all 3 of them, right? Right? So, when it's all put together like this, don't be scared by it. Go step by step. What happens right there over brackets? Multiply. So it's 1.5 to the 15th over 1.5 to the 5. There's 5 on the bottom, there's 15 on the top. How many of that 15 is disappearing? 5 of them. 1.5 to the 10th. Couple of ways I could do 8. One way I could do 8 is I could do inside the brackets, or I could do the exponent laws, couldn't I? So I could have 8 to the 1/3, a to the 1, and b to the 2. 8 to the 1/3 is the cubed root of 8, so it's 2ab squared. One way I could do it. I could also do it this way. What's the base in number 8? A3B6, right? Because it's all in brackets, yeah? Well, we know that 8 to the 1/3 is the cubed root of 8, right? Because the base goes under the radical sign. So couldn't this also be the cubed root of 8a3b6? Then I just do the cubed root. Cube root of 8 is 2. A3, I can get out a single a. B6, I can get out 2 b's, and I left nothing under there. And I get the same answer. Yeah? 9 is one of the more difficult questions I could give you. Because it's freaky looking. Because of fractions. But it's not freaky looking, is it? Because what is it really? It's really 4 over 2, which is what? 2. And then it's a to the negative 2 over a squared. Where should that negative go? Down there and become what? A squared. A squared and a squared is a to the 4th. So I got to have an a to the 4 on the bottom, right? And then b to the 2/3 over b to the 1/3. Well, if there's 2/3 up top and 1/3 down there, how many of these 2/3 are canceling? One of them. So that's going to be b to the 1/3. And he stays in the numerator. Is that done? Yeah. Could you change the way it looks? Can you do something with this? If you wanted to? You could make that 2 cube root b over a to the 4th. Which do you think I want? Which one of those shows me the most mathematical knowledge? The multicolored one or the all blue one? The all blue one shows me the most knowledge, right? So if this question were out of 4, this gets you the 4. This, I'm so nice because it's such a hard question, would get you 3.5. Does everybody understand? Okay. What do you want to do with 10? Because 10 is a real bear. What do you want to do first, Joginder? Number 10. Not the answer, just what would you do first? Not sure? Who can give me an idea of a first step there? I know you can. Somebody else. Give someone a chance. Pardon me? You would notice that isn't this the same as square root, that whole thing? Okay. So could I take the square root of 100a over 25a5b to the negative 1/2? All right. Well, isn't that then, okay, the square root of 100a over the square root of 25a5b to the negative 1/2? All right. What's the square root of 100a? 10 square root a, right? Right? Over, what's the square root of 25? 5. A to the 5th, I can get out a squared. And b to the 1/2, can't do anything with that. So now I've got a to the 1 and b to the negative 1/2. This is getting barfy, isn't it? It's yucky, right? Okay, so we could continue, but it's probably not a very good idea, is it? Because this is a mess. Although, isn't it 10 root a over 5a squared root a root b to the negative 1/2? What do you see right there? Cancel them out. So they end up disappearing. What about 10 and 5? What's 10 over 5? 2. And now on the bottom, I've got a squared root b to the negative 1/2. Right? Could you get to there? You could. Are you done? You could be, but you could simplify this. We don't like that negative, do we? We don't. So where's it got to go? We can bring it up, but it's got a square root, right? So we're going to bring that up here, and it's going to become the square root of b to the positive 1/2. Now are we okay? Could we go any further? You could, because isn't this b to the 1/2? Right? Because this 1/2 is technically under here, right? So isn't that b to the 1/2 to the 1/2, which would be b to the 1/4? So I get 2b to the 1/4 over a squared. Barf. Yucky. Did we get there? Did we get to a final answer? Now, the problem is, what Parm did to start with was not the simplest thing he could have done. Parm brought previous knowledge. He brought this to the party, right? Because he saw, oh, it's all a base, it's got a square, right? But when he did that, he got a big giant mess, yeah? I submit, and I'm going to erase this, even if you have it, you've got the right answer, don't worry about it. I would say, before I jump into it, I would say, maybe I want to tidy up inside there first. What's 100 divided by 25? 4. A on top, 5 A's on the bottom. So that A disappears, and there's 4 A's on the bottom, right? And that negative 1/2 b comes up here and becomes positive 1/2, yes? Now all that's to the 1/2. Now that's a little tidier, yeah? Because now I get 4 to the 1/2, b to the 1/2 to the 1/2 over a to the 4 to the 1/2. 4 to the 1/2 is 2, b to the 1/4 because that multiplies, and what's half of 4? A squared. And you can do it all in one step. Almost. Why am I doing this to you? Why am I saying, following Parm all the way down, 35 steps, and then saying, but couldn't you do it in 2? Because it doesn't matter. And because if you make the mistake of not bringing all of your math knowledge together and looking at every question before you even start it, what's the best way to approach? You're going to make errors. If you learn one way and say, I have to do it this way, and it's not the fastest way to do it, you're going to be screwed over, right? That is what I mean when I say bring all of your math knowledge to every single question. Because even if something works really well up here, where we just cube rooted, down here, that got a little barfy, didn't it? And we're able to follow it, but why would you go on a path that looks like this when you can go on a path that looks like this? Nice straight line. Everybody with me? Who makes that decision? You make that decision. But you have to know all your options, which is why I assign practice to you. Everybody cool? All right. Now, this question every kid does wrong. Because every kid goes right to here and goes, okay. X is -2. -2 to the 3/2 times, y is 3. 3 squared. X is -2 to the 1/2. Oh, damn it, that's the square root of 2. Y to the negative, that's 3 to the -1. Oh, damn, 3 to the -1, that's a denominator, 3 to the 1. Barf. Every kid substitutes first. How many of you immediately looked at that and thought, I can put stuff in for X and Y? Be honest. Yeah, of course you did. What's the number one instruction in every math question? The first thing every math question says. Starts with an S. Ends with a Y. Has implify in the middle of it. Simplify. Simplify first. What is 3/2 plus 1/2? So that's x to the 2, right? What is 2 minus 1? 1. Now, what would you rather put -2 and 3 into? This or that? The green one or the circled one? The green one. Simplify first. X is -2. -2 squared. And y is 3. What's -2 squared? -2 squared. The negative's part of the base. 4 times 3 is 12. Now, if you'd gone the other way, putting it in there, you would be in a big, giant mess. So let's look over here. Simplify first. Where can we start simplifying? Inside. Can I deal with that or that first? Yellow or green? I would deal with the green. That negative base has a positive exponent. So what's going to happen to that negative sign? It's going to stay there? Wasn't this a negative base with a positive exponent? It cancels out, doesn't it? So really, I've got x to the 4th, and what will this become? The negative will cancel, and it will become what? x to the 12th cubed, right? What's 4 and 12? X to the 16th cubed, which is what? -48th. What's x? -2 to the 48th. Will that be a positive or a negative number? Positive. Will it be a small number or an absolutely gigantic number? What is it? Because I said to evaluate. I can't do that in my head, but you can. Well, not in your head. You can do it with your calculator, but it's going to be a giant number. It's like 2 trillion, right? Most of your calculators won't even show it. It probably shows something like 2.81 with a little 14 up here. Yeah. That means it's 2.81 with all those decimals to the 14th. This decimal moves 14 places. It's a crazy, gigantic number. Do I need to review this? I think I do need to review this because it's algebra. Volume of a sphere, 4 pi r cubed over 3. Where does that 425 go? Where's that 425 go? Volume. 425 equals 4 pi r cubed over 3. How are you going to get r by itself? You get rid of everything around it. Cancel, cancel. 3. 1,275 equals 4 pi r cubed. How do you get rid of 4 pi? How do you get rid of the cubed? Cube root. Now, if you got to there, have you shown me some math knowledge? Yeah, a lot. Have you shown me any math knowledge from this current unit, which was radicals and exponents? Very little bit when you remembered that cube rooting this would get rid of the r, right? So, if you stopped there, you've done good work. But have you done any work on this current unit? Not very much. So what would I have to give you? 1, 2, 3, or 4? I'd give you 2 because you recognize the square root. You got to a basic, or the cube root. But to get the full 4, that's the cubed root of 1275 over the cubed root of 4 pi. Now, I haven't taught you what to do when there's a root on the bottom. So you would have to leave that alone, right? Because pi doesn't have a cube root, and 4 doesn't have a cube root. So the bottom is stuck, but could you fix up the top? We'd break it down, and we'd look for groups of what? 3. I'm not going to do that. I trust you guys can do your division. Right? I want to get you to your work time. Everybody's okay with that? You know what I mean you would do here, right? You'd simplify here. Just like we already know how to do. Down here, a cone with equal height and radius and a volume of 18. Well, volume of a cone is pi r squared h over 3. Equal height and radius. So what does that mean r and h are? R equals h, doesn't it? So 18 equals pi. R and h are the same, so that's really r cubed now, isn't it? because r squared and h is the same as r cubed over 3. And then I do the same thing. 18 times 3 is 54 equals pi r cubed. R cubed equals 54 over pi. R equals a cubed root of 54 over pi. 2 marks to there. Finish it off. Cubed root of 54 over cubed root of pi. You have to stop at the bottom because you don't know what to do with a cubed root down there. And up here, you'd simplify that. Of course, that's 27 times 2, so it's 3 cube root 2. And everybody should be good. Now, of course, remember, in the real world, you would have had almost 2 weeks with exponents and radicals. You got 2.5 days, right? It's tough. I am with you. I understand. I feel your pain. But that's the nature of the beast. That's how it is. So we got to deal with it, right? So everybody should be good to go. If you want, as always, page 45 and 46, 47 is just the answers to 46, have all kinds of practice with the answers. It's not worth anything, but the next page, 48, is worth something. So maybe you want to practice a bit before you go on to the stuff that's worth marks. All right? Now, please notice, we have 15 minutes left in this block. That third block is polynomial multiplication. You all can do that in your sleep. That's why it's in the third block, because it takes 10 minutes to remind you of how to do it. Then you're going to get work time and work time. All right? We'll mark this review near the very end of the day, like 1 o'clock. All right? That polynomial assignment, when would we be marking that? Tomorrow. Your exponents and radicals test is tomorrow in second block. All right? So, 20 minutes now to work on exponents and radicals. I would do a little bit of practice if I were you before I went to this. Or maybe you want to go to this, do everything you can remember how to do now, do a little more practice, then come back to that. You decide what works for you. I do not like telling you people how to go about your work. All right? But you got 20 minutes now to use as you see fit. When you come back from your break, I'm going to use 20 minutes more of your time to review multiplying polynomials. Then I'm going to shut up pretty much for the rest of the day except to help you. Okay? Go.